everyone to the webinar on implementing research data management for labs and grant. My name is Amit Chourasia. I lead the visualization effort at San Diego Supercomputer Center, and I'll be the host for this webinar. Okay, so let me share my screen here, and then feel free to ask questions as they come. I'll try my best to answer them as they come, but then if there are any leftovers, we'll discuss them again at the end of this webinar. So can someone confirm that my slides are appearing okay?
Yes, I see them.
Okay, perfect. All right. So here is kind of logistical information around the webinar. There's some presentation slides if you're interested in, and if you're interested in having a conversation after the webinar, feel free to schedule a time. I already know some of you already picked this option earlier, and I'll be reaching out to you. But if you haven't done that, and if you feel like a conversation would be useful, feel free to schedule it or get that link at least. Okay, so this in this webinar, what I'm going to cover is common kind of problems which the stakeholders face, and then what SeedMeLab is and how we are kind of trying to address those problems which we often come across in research labs. And then finally, we'll discuss, data management plan and how to kind of go about addressing those things for sponsors, and then implementing a practical plan for your lab or grant. Okay, so once we start to kind of have data in the lab, we have typical stumbling blocks which more or less everyone come across, which is how do you where do you store the data? How do you move the data there? How do you enable access control, or how do you enable collaboration on your data set, and do so privately? And then is there a way to do some automation for data movement and data management? And so a lot of ad hoc solutions are built by research groups which are used to kind of overcome these things to some degree or the other. However, these ad hoc solutions are become quite hard to kind of use over time, and they become impediments in kind of sharing information and getting past information back, which is quite valuable for the PI or the stakeholder, for which actually owns the data over medium term. However, data is not everything. While data is very important, there is context around that data, whether what protocols were used, what parameters were used, how things were computed, and so forth. And all this information is scattered on different systems. It could be in emails, it could just be remain in meeting discussions, or it could just be in people's head. And this information is quite relevant after the data has been sitting there for some time, and it becomes harder to use or manage. Also, it is often an issue with research labs that they don't really have a tight control on where the data should go. Sometimes there is one, but other times people put data all over the place, and it becomes harder and harder to kind of synthesize where things are and manage this. The data presentation, which we are generally used to, is quite utilitarian, and which works well. We have a listing of files and folders, but it is bereft of the context, and so it doesn't provide us a lot of information beyond file names and size and so forth. However, those contextual information is quite important to kind of gather what was done, how it was done, and so forth. Also, sometimes visualizations can be useful for presenting the data in a visual form that can convey, at least some form of compact information beyond just looking at the files. And while the data exists in some place, it becomes harder and harder to find after some period of time. And so I like to use the term dark data. That means it exists, but it becomes harder to find over time. And then if it's hard to find, it's hard to use and reuse as well. So the stakeholders have a set of issues which happen in a recurring basis, right? How do you manage your preliminary and transient results? This is hot information which gets generated routinely, and there's a lot of information in them, and there's a lot of way the research gets guided by these preliminary and transient information, and sharing them, and allowing the information to be richer beyond the data files and things like that is really important. And then also, once the research is kind of almost concluding for a project, there is a need to disseminate the data products. How do you go about doing that? And then how do you integrate this contextual information with the data itself? And then finally, how do you search these data products and get back the information which you already have worked so hard to kind of put in place? And then there is an issue about, how do you do transitions when students graduate, postdocs leave, and then new people come in? So how do you do an onboarding of new participants, and how do you do the handoff from outgoing participants? So these things are recurring in nature, but there is more problems for stakeholders that essentially who will implement this data management? How will it be implemented? And do they really have the time, expertise, and the tools available to implement the data management system and maintain it over time? So there's a continuity aspect of it, the maintenance aspect of it, and the tooling aspect of it, and most research labs are ill-equipped to kind of deal with these kind of things, and their time is better spent in doing the research anyways. So for our project, the things which came out from our experience working with a lot of researchers in different disciplines is that if possible, a portion of the data may be made available on the web. And once it's made available on the web, it should be accessible through the web browser, obviously, but it should also be accessible through APIs, so it can be integrated with systems and applications. And also it should be accessible from command line. So if you're running on a cluster or a supercomputer somewhere, you should be able to interact with the data management portion and move the data and access it programmatically or through the command line as well. And then we obviously want access control to share the data either privately or publicly, or with read or write privileges with others. And more importantly, we want an ability to annotate context or metadata or something else with the data, because files and folders are not everything. We need a lot of other information to make most out of them. And so how do we kind of integrate or fuse these other elements with the data, so that when we go back to kind of find them or look them up, all this information is available to us. And then finally, is it possible for us to present this information in a rich format? Surely we can do the listing as files and folders, but can we do better? And so we built this on a software framework. We wanted a lot of properties in an underlying framework when we built this thing. And in summary, what we wanted was a system that can be deployed easily and can be distributed and used by many people with ease. And also, we were interested in having a framework that is managed by a large ecosystem. So it's not a software product which is only our group develops and nobody else knows in the world, and then we are the only the shepherds of that system. So I think having investment by other large community of developers is very important, because data, depending on a very a small fragment of people over a long term is a risky element, and we wanted to minimize that. So in our case, we chose a framework called Drupal Content Management System. And it's a fairly mature content management system. It's been around for a long time, has a tremendous amount of adoption, and it's open source as well. Very strong community. In fact, this is one of the largest community which is comes together and builds this software. I think the only software which comes to mind, which possibly is bigger than this, is the Linux software itself. And there's a lot of support and commercial entities also that use and develop the system. So very, very good support from the community point of view, good buy-in from different stakeholders as well. Drupal content management system comes with lots and lots of contributed things, and a lot of things is available in the core, which means we don't have to develop those things. Those things are already available. And as I mentioned, heavily used across different sectors, a lot of adoption in academia, government, and so forth. So here is a quick glimpse at the architecture. The system is built on a Linux, Apache, MySQL, and PHP web stack. This is the web stack which is more or less powers most of the internet. There are new paradigms emerging as well, but this is kind of a standard thing which has been around for a very long time. Fairly scalable, well used, and people know how to deploy these things fairly easily. And so you have a server which basically hosts all those things in a database, file store, and a web server which serves all this information back to the client, which is going to be a web browser or a REST client. And in our case, what we do is we have developed very specialized modules for data management that plug into the Drupal content management system. And then we also provide a client. So one doesn't have to write code to use our APIs, but then there is a client available which doubles up as a command line client and also as a software development kit for integration with other applications. Okay, so here is a quick look at the system.
Is your data accessible to all your collaborators? Sure, your data is on the cloud, and others have access to it. But often the context of that data is limited to few team members with crucial insights lost in meetings and emails. Over time, it becomes hard, then impractical to find information, or sometimes even reproduce results. So how do you improve collaboration, boost knowledge retention, and maintain continuity with changing team members? The answer is SeedMeLab, a web-based system that brings everyone's input and data into a single system. With SeedMeLab, you can store and share data, figures, equations, descriptions, and comments. Everything is indexed and searchable, so you can quickly find relevant notes or data, and never lose those insights ever again. SeedMeLab is packed with powerful capabilities. You can extend the file system to store additional metadata, visualize CSV and JSON files, and add plugins to present other file types. Integrate with your existing system using the REST client, and add personality to your data with custom theme and domain name that reflects your brand. SeedMeLab manages all your data and its context in a unified data management system and is accessible to you on the web. Search, manage, visualize, and share your data like never before.
So that's kind of a quick preview of the system. So let's get into the details. When we think about data, we think about 5 Ds. There's the data, there's the description about the data. What is the discussion which is happening around data? How do you present or display the data? And then how do you discover the data? So I like to think about this as 5 Ds for data management. In our case, we have several use cases for the system. We offer and set up a system like this for different research groups. There are several groups which are already using the system for either private collaboration or sharing their data with others. We have some scientific applications which have been integrated with our system, and we are developing new applications as well on top of it. And then we are also, providing it as a service to our HPC users, where an instance is available to our HPC users for sharing their data, which they compute on our clusters. Our core software is open source and is being actively used by fairly modest amount or moderate number of people, and we continue to kind of support it and manage it and continue to be good shepherd of our software and make it usable by others. Again, we got some recognition last year with R&D 100 award as well, and some good kudos from our users. So let's take a deeper dive into the SeedMeLab system and see its capabilities and features and how it can potentially fit into your workflow. So first up is, how do you use the system from a web browser? So here is a quick video around it.
Managing data on SeedMeLab via web browser. Let's take a quick walkthrough of using SeedMeLab. Log on to your SeedMeLab site. Head over to the data page and use standard file management operations available via File and Ancestor menu icons. Start by creating a folder and renaming it. We can describe this folder with equations, images, tables, etc. Now, upload multiple files into this folder. We can add description to any file also. Descriptions are displayed along with file or folder and are searchable. Any file or folder can be discussed via comments at its location for easy collaboration. Find and discover files not just by file name or file extension, but also by keywords that may be found in descriptions or file content. Navigate through parent folders using breadcrumbs or the Ancestor menu. Files may also be uploaded using drag and drop into the table region. Now, let's step through a set of images in a slideshow to assess them. Move files to a child folder via drag and drop or using the move operation. Select desired files and folders, then download them easily. Sharing can be performed from top-level file or folder, which greatly simplifies access management. From personal files, share a folder with site members, granting them desired access privilege. To share data with non-site members, use the invite operation in the same way. Opening files such as simple CSV and JSON displays automatic visualization. Few other file types, such as protein and phylogenetic files, can also be visualized. New plugins can be added to visualize other file formats too. SeedMeLab works just as well on mobile devices also. Unify your data, description, discussion, and discovery in one spot with SeedMeLab.
So that was a quick walkthrough of using the system through a web browser. Let's take a quick look at customizing SeedMeLab and its features. This is behind the scenes.
Customizing SeedMeLab's key features with administrative privileges. SeedMeLab includes extensive set of features that could be customized to meet different needs. Log in as administrator to your SeedMeLab site and dive into configuring the Folder Share module, which provides the core data management capabilities. Restrict the file types that could be uploaded or limit the maximum upload size for a single file. All menu commands are implemented as plugins. New command plugins can be developed to provide custom capabilities such as data validation, analysis, or other features to the end user. Search can be configured to limit indexing of file types to a particular size. Usage report can be updated at periodic intervals. Visit the folder share usage page to view storage used by each user. From the Ancestor menu, the administrator has an ability to view all data on the site. Folder Share module also has configurable permissions to grant specific capabilities for different user roles. Now, let's configure SeedMeLab's file system. Visit Manage Display option. Here we can see several formatters that generate visualizations for different file types. Custom visualization plugins can be developed for desired file types. Using the Manage Fields option, we can see the stock Folder Share Comments field. We can add new fields of various types to the SeedMeLab file system to store additional metadata for all files and folders. Now let's review a site that already has keywords, experiment date, and license fields added to the file system. Note, when new fields are added to the file system, they are global and become available at every file and folder. Display order of all fields shown on a file folder page is customizable. For example, here we change the order of new fields. These changes are global and affect every file and folder. The file system has an operational REST services that can be enabled if needed. SeedMeLab provides a ready-to-use REST client. This client includes an API and a command line utility. SeedMeLab can be configured to function as a full website too. For example, here we enable a pre-configured template website for a research lab. In-depth customizations can be made to the website. Lastly, SeedMeLab theme can be customized to reflect your branding with desired look and feel. SeedMeLab's comprehensive configuration and customization options make it a versatile platform for collaboration hubs, data repositories, application portals, and more.
I think my computer is freezing, so I'm going to restart and be back in a minute.
Our speaker will be right back. He's just restarting his computer due to some delays. Thank you for your patience. And again, if you have any questions, please feel free to put it in the Q&A and we'll answer it towards the end or slip it through the presentation. For anyone who's just joined us, I did put a link in the chat box with the slides for you to review.
Well, pardon me, I had some technical problems here, and just give me a second and I'll get started here. Okay, so give me a moment. Okay, can you see my screen?
Yes.
Okay, perfect. Sorry about that. So I think the video froze, right? I was not able to see after a point, and I presume you folks didn't see it either. I think about a 1 minute left or so.
It actually worked just
folder.
fine a bit.
Pardon me?
It actually did play while it was actually playing.
Oh, it played all the way through?
Most of it.
Most of it, yeah.
Yeah.
So I think about a minute was left. So let me just play from here and then we'll go from there. So this is the last video. Okay.
Display order of all fields shown on a file folder page is customizable. For example, here we change the order of new fields. These changes are global and affect every file and folder. The file system has an operational REST services that can be enabled if needed. SeedMeLab provides a ready-to-use REST client. This client includes an API and a command line utility. SeedMeLab can be configured to function as a full website too. For example, here we enable a pre-configured template website for a research lab. In-depth customizations can be made to the website. Lastly, SeedMeLab theme can be customized to reflect your branding with desired look and feel. SeedMeLab's comprehensive configuration and customization options make it a versatile platform for collaboration hubs, data repositories, application portals, and more.
Okay. So I have one more video, but since my computer froze, I'm going to skip that and then post it as a comment, and maybe should do it live. And this is about using it.
Amit, I wanted to jump in. Actually,
Yeah.
we had a question in the Q&A.
Okay. All right.
It says, let's see, can we write our own module? Like for some file types, can I use my own code to make a custom module?
Absolutely, yeah. That's the nice thing about having a modular system, that not just you can so the customization and development option is not just available only for displaying the file type, but it's also available for any other data management operations that we see. So like we were seeing here, the file management options, they can also be, they are also plugins, so they can be changed to something else. Yes. So yes, so it's a custom visualization modules can be added. Okay. So I'm going to skip this one, but this essentially video shows how to use the command line client to manage data on SeedMeLab instance. Okay, so let's move forward.
Data on.
Okay, so let's talk about data management plan for labs and grants. So most of the sponsors are now requiring a data management plan. This is well known at this point. The less well-known thing is that behind the scenes, the sponsors are actually starting to be more strict about reviewing this data management plan. It's unlikely that this plan will make your project or fund it, but it can certainly make cast some bad impressions if this plan is not developed in a thorough manner. So there's some thought needs to be put on into how a data management plan document that would be submitted with a grant is actually reviewed favorably and have a positive net contribution to the proposal. There is a lot of language provided by the sponsors about open data and fair data, and those things are being mandated. While these are broad principles, the implementation of this is left out to the research groups and how to figure those things out. So some ideas around data management plan is that sponsors are not really keen to see templated data management plans. Each research grant or a proposal is independent and a separate entity, and hence the data management plan for each should not be a copy of a template. It should be developed for that project and how it makes the project kind of bring more value to the community and beyond. Also, a less known thing is that NSF allowed using of funds since 2018 for data management. And the interesting aspect about this is not only grants can allocate funds for data management during the award, but it is also possible to allocate a little bit of funds after the award. And this can only be done if you write this in your budget document in your proposal, because these things cannot be done afterwards, or you have to get approval from your program manager or so forth. So many times a sponsor would ask that how long are you going to keep your data available or the artifacts available after your award. That is an opportunity to write some amount, whatever it may be, to maintain some of those things beyond your award period. So it may be 2 to 3 or 5 year period. You can allocate some funds to maintain the artifacts produced during the grants that can be used. When we look at data management aspects asked by the sponsors, there's some common language there. The data types, what kind of data would be generated or used, what are the standards. This is fairly straightforward for any research lab to put together. Then there is a portion about how do you maintain accountability about who's going to manage the data, what will be people's roles and responsibilities, and things start to get kind of a little bit tricky here. And then there is a issue about data access and data sharing in practice. So there's a ask about how will these things be done, and more importantly, which methods will be used to make data or metadata available to others. And this becomes a wild west on how you would be doing that. So research groups have to often implement something on their own to kind of accomplish these things, or not do this altogether, which is a problem. And then there is an issue about policy, about how would you, what kind of license essentially you're going to assign to your data for reuse, redistribution, and production of derivatives. And there are, this is in some ways at odds with the open data and fair data principles, because sometimes you want to make the data available, but not necessarily for commercial purposes, or there may be sometimes ITAR regulations or some other regulations around it, where you may want to protect that data, and how do you kind of go about doing that? And then finally, there's a information requested typically for how the data would be preserved beyond the grant period. And then if there is no repository or anything like that is available, how would you make that metadata available on the internet? So these are some things which need to be addressed in a data management plan. Some of these are straightforward or trivial. Others are problematic. And with SeedMeLab, we can address some of these fairly easily. And that's the contribution which we bring for the research labs and grants. So the way to kind of think about the data flow, if you would, is that when the research is initiated, you may collect data from various devices or instruments. And the idea is that the initial data is great at where it is for some period of time. But then as you start to develop interim products or preliminary results and things like that, they need to be then shared with the group, with some outside collaborator, or sometimes even beyond to community, and sometimes even to public. So how do you do that in kind of a scalable way? And so the SeedMeLab instance allows you to kind of not only organize your data, but also annotate it with metadata and context, and even discussions so we saw in the videos earlier. And then there's an ability to do access control on them. And then there's also an ability to spin up a website around it also if needed. And then, of course, your file servers and services could also be another place where, the raw data may be kept. Or if it's very, very big, you don't want to move it too often on too many places. So some of that can persist there, but other more kind of consumable results can be distributed through, a SeedMeLab instance. And then finally, when we are looking at preservation, what options are available for preservation? The very first option for preservation the groups generally look at or should look at is there a domain repository available for your research area? If there is one, that's a great place to move that data there. And the good thing is if the data is in SeedMeLab, a lot of elements, a lot of context and metadata has already been added there. So moving this information at the end becomes much easier than it would be if all the context and other information was spread around in too many places. In many cases, a domain repository is not available. I think many institutions have a policy of providing an institutional archive. UCSD has one, and so that is a good place to move the data to that archive where it's preserved for a longer term. And again, if you have all the data, metadata, and context, it becomes much easier to provide this information in the form these archives desire and make them available. And as sort of a last resort, there is this archive called Zenodo set up by CERN, and that is accepting data from any domain. And they currently have a preservation plan for at least 20 years. And so that is another place to kind of, make a copy of your data if you don't have a domain repository where it could be discovered by others. So the way we are helping our research groups and lab is we are providing guidance and help on writing this data management plan document. We can also provide a letter of collaboration or commitment if it helps to make your proposal stronger. We are setting up an instance of SeedMeLab for research groups, so these can be branded, they can have the domain name of the research group and so forth. And these instances will host data for your group. There is also a baked-in website which can be enabled if useful. And then we provide training to the lab on how to use the system and field any questions and offer support. And any customizations that are needed, we do that as well. And then finally, there is a need to, sometimes there is a need to develop visualization for a data type that may be produced recurringly by a lab. Well, we can help write those plugins or write those plugins and install that on the SeedMeLab instance. Or if there is an application that needs some sort of integration, that can also be performed. So we actually rolled out a new service a few weeks back. And then we offer it in 3 tiers. And I don't want to go to all these features. That's also available on the website. We got approval from UCSD a few weeks back on recharge for this service. And so the pricing is available on the website, and it's available for the UC customers for it's published there. But even external customers can use the managed hosting, and we can provide pricing for that as well. I want to acknowledge various folks who have helped make this project possible. In particular, I want to acknowledge National Science Foundation, which actually funded this work. And then after the completion of the grant, SDSC also funded this work to make this more sustainable and as a service as well. And there are a lot of other folks involved, developers, students, and SGCI as well, who provided consulting on various aspects. So for a discussion, this is, I think, a good time for us to kind of break out into a discussion. And if there is interest, I can actually show the command line management of data, or live or through a video. But we can also kind of break out into a discussion. And so I can post these on chat as well. You can reach out to us in that email. There's the presentation slides. I think they are already available on chat. And, of course, welcome to schedule a conversation to discuss things more in person at a later time. So let me post this.
I just posted it.
Perfect. It's already there.
Yeah.
Perfect. Yeah. So let's see if there is any question which is out there or pending. Okay, so Ganeshan has raised his hand. I don't know, do they have the ability to unmute?
They can, yeah.
Okay, go for it.
Okay. So I was the one who asked a question regarding like writing my own modules.
Right.
So when you were giving the presentation, you told like when we can ask you to develop new modules, and you will be developing those modules and integrating them with the website, right? So I was just curious, like if we can create our own modules and integrate ourselves by using the command line prompt, SSH or something like that, or should we give you the our needs and you will be developing it on your own?
I think both things are possible. I think what your question is that so I think it depends who's hosting it, right? If you're asking us to host it, right? Then obviously we need the code to kind of add it to our the hosting infrastructure, right? But if you're self-hosting it, right, then of course you have full control on how you kind of go about doing these things yourself. So I think it's kind of a trade-off, right? I mean, not everyone is interested in maintaining and developing these things, but then there are some people who are more technically savvy and they have the resources to do these things. So both things are possible. Even if you're hosting with us and if you want to develop plugins, you can share those plugins with us, and then we can install them.
Okay. And you guys also provide a server space, or you can install your service in our server space, right? Both are possible.
So I mean, the thing which I mentioned here is a fully managed service. We take care of everything, right? But then if you are interested in just getting the infrastructure, let's say you want to have your own instance and everything, there is another way at SDSC which you can go about doing that. In that case, it's all managed by you, and then SDSC just provides you the infrastructure. In this case, we manage everything, so we'll do security patches, we'll provide support and all that. So I think it's depends what model works best for you, and you can pick one over the other.
So if we want to do extensive customizations, then it would be better for us to host and then to use your service in our server, right?
And not necessarily. It depends, right? I mean, what it is that you want. I mean, if bulk of the work is what you will be doing, then obviously you want a lot of control and ability to kind of do things in line. But then if you want us to help you with the development, then it doesn't really matter. So I can give you an example here real quick to see, you can get a sense of this. So here is an example. So we developed a fairly sophisticated portal for JCVI. And so the idea for them was they wanted to upload clinical data, which goes through a de-anonymization routine, then it goes through some data validation routine, and then it goes through some data transformation. And then they wanted some interactive visualization to construct what they called gating graphs. And so this is what it looks like. And it basically, once the data comes out of the instrument, it basically gets uploaded, and there are new options available for data management, which basically says, hey, validate this file, whether it has all the content which is supposed to be there. And then there is some custom user interface which was built to kind of make these gate trees, which you are seeing this tree diagram here, and add metadata around it. So let's take a quick, and then there is an ability that was developed to do reports, and and there are some internal processes which run, which basically do plotting of the data, transformation of the data, clustering, filtering, and so forth. So there is, underneath the hood, there is a lot of tooling that does data transformation and things like that. So here is a bunch of data, and then you can transform it based on the criteria which was provided by the researchers. And these are all custom elements that were built. And like I was saying, this contextual menu, in addition to your standard data manipulation options, you can add a plugin to do other things to the data, right? And so in this case, it's like creating reports or editing a gate tree, and importing, exporting, and so forth. So here is an example of a tree being constructed. So a new node has been added to a tree. Then some parameters for that node are being added. And then, you select different parameters, and then a visualization gets generated. Then you select a window around it, and then you go on and add in these nodes and construct the remaining graph. And then, you can go back and forth between this tree, and you can see what it does, and then generate reports and then share it with others. So this is a very, very customized example of things which we developed on top of modules for SeedMeLab. So this is a very custom application. We don't run it. They want to deploy it in the hospitals, so they manage the infrastructure. JCVI's IT manages all this. And so we did the software development for them, and they just install it and do that. So again, all these things are possible. You can develop it. You can ask us to host this. You can still host the server and other storage at SDSC, but then you still maintain and manage the development. So all things are possible.
Oh, okay, so even if we have if it is hosted in SDSC server, we can have complete control over the.
Yes, you can. I mean, that's a separate sort of thing. Then you can just SSH and then just drop in your code and do whatever is needed. That's also possible.
So it's like completely open source. Okay.
Pardon me?
I'm sorry. It's like completely open source, right? So.
Yeah, the software code is available. Yeah, and so if you go to our website, there is a. Let me show you where it is. So if you go to community, if you see this get started, there's a link to the different modules. But if you go to get started, there is a Docker recipe. In a few steps, you can bring up a site on if you have a Linux system, you can bring it up. Now, where you bring it up, you can bring it up on your laptop for testing, or you can bring it on Amazon Web Services, or wherever you see fit. I mean, you don't have to use Docker, but we provide it with Docker, so you can see what's going on. Yeah.
And the pricing for just the service, without the hosting, is it also available in UC San Diego website?
Right. So if you go to our website, we list the price in there, and then, you can have a conversation with us if there is something specific that you're looking for. And so, by the way, these costs are on cost recovery basis. If you're not aware, we can only charge for what it takes to run these services. We don't charge more than what it runs. So it's not a commercial operation if you look at it that way. And so many times, we are working with researchers. Sometimes the labs do not necessarily have the funds available right now. And when they're writing a grant, we help them with the data management plan, and they can bake these prices or costs into their grants which are going, and then leverage them when the funds become available. So we work with the researchers to make it as easy as possible to kind of absorb these costs into for ongoing work.
Thank you so much for answering my queries.
You're welcome. All right, any other questions? Yeah, if there are no other questions, I can play back that video. We have a few more minutes. Of course, I don't want to hold you back much longer than what we initially planned for. So here is a quick video, but feel free to unmute and ask a question if you have one.
Data on SeedMeLab can be managed via Folder Share REST client. This client may be used on the terminal as Folder Share Shell, or included in scripts as shell commands, or integrated with your applications using the API. Start by downloading the Folder Share REST client from your SeedMeLab site, which is implemented in PHP. If needed, install PHP on your operating system. macOS already includes PHP. For convenience, add environment path to the Folder Share REST client folder. First, check the Folder Share client version and make sure that it is compatible with your SeedMeLab site. Now, let's begin with interactive usage on the terminal as Folder Share Shell. Review help for the Folder Share client. Most commands are similar to those found in shells such as bash. Log in via command line with your host name, username, and password to enter the Folder Share Shell. Type help to view available command set. Then see help for the list command. Similarly, review help for make dir command. Then use it to create a few remote folders on your SeedMeLab site. Then list the newly created remote folders. Note, all local and remote paths must be absolute. View help for the update command. Then use it to add metadata to any remote folder. You can add descriptions to any files too. Display help for the upload command. Then transfer a single local file to your SeedMeLab site. -v and -p arguments display progress and preserve timestamps respectively. Next, upload an entire folder also. The sync argument will upload missing items from local to remote destination. Now, list the remote folder to see the uploaded files and folders. See help for the download command, then transfers a single file or a folder. The optional sync argument downloads the missing files from remote to local destination. Copy and move commands can be used with wait arguments that halts the return until the operation is completed. This is useful when subsequent operations depend on this command's success. The remove command with rf argument will recursively delete a folder and all its content. Use the quit command to exit from the Folder Share Shell. To share the data with others, log in via web browser, then use the share and invite actions from top-level files or folders under Personal Files page. Now, let's take a quick look at folder share commands for use with scripting. Enter the required arguments for hostname, username, and password, followed by desired command such as list, make dir, upload, etc. as used earlier with the folder share shell usage. These long-form commands can be composed into desired scripts. Now, explore the different output formats that are available. Linux format displays output in a terse manner, and the text format displays output in colon-delimited form, which can be used to fetch file or folder's description. For brevity, store the common folder share arguments in a variable, then concatenate it with desired commands. Folder Share REST Client API may be used for deep control and integration with your applications. Now, let's take a quick look at API files. The Folder Share REST client for SeedMeLab provides a versatile tool for command line interaction, scripted automation, and integration via the API.
Okay, looks like my video is freezing again, but if there are any questions, we can field them through the audio. Cindy, can you, any chance you can keep an eye on the Q&A if there is any?
Yeah, I've been looking. There's none at the moment. And we're actually almost at 1 minute till 1. So.
Okay, so if there are no further questions, let's adjourn. You can feel free to take a note of the links which we provided earlier and connect with us if you're interested in further information or a conversation with us. And thanks for joining us. All the best with your research.
Thanks, Amit.
All right, bye guys.
Bye.